Yeah, so we'll be discussing problem C today. So the name of the problem is sum of substrings. So here is the problem. So you are given a binary string s of length n. Let's define di as a number whose decimal representation is si and si plus 1. We define f of s to be the sum of all valid di. In other words, f of s is summation di from 1 to n minus 1. So they have given example string over here. So let's say s was 1011. So d1 will be the integer value of the first two digits, that is 10. d2 will be second and third digit, that is 01, which is equal to 1. Then d3 will be for the third and fourth digit, that is 11. So the f of s is the sum of all the di's, which comes out to be 22. So now this is the operation that is defined on a string. We are given a binary string. So now in one operation, you can swap any two adjacent elements of the string, find the minimum value of f of s that can be achieved if at most k operations are allowed. So let us look at the sample. Uh, for the first sample, let's copy it to, yeah. So for first sample, we have 4 and 0. That means we have 0 operations remaining and the string is 1010. That means it is 10 plus 1 plus 10, which is 21. Now for the second sample, we have the string 0010 100. Currently, the face value of the string is 0 plus 1 plus 10 plus 1 plus 10 plus 0, which comes out to be 22. Now we have one operations that we can do. So if we think and like you guys can think and try, but no operation will bring the face value down from 22. It will only remain 22. Now let's take the example, third example, 00110. So the current face value of the string is 0 plus 1 plus 10 plus 10 plus 0. Sorry, here comes 1. 1 also comes over here. Uh, no, wait. 1, 11. This is 11 plus 10 plus 0. So this is currently 22. Now, if we are allowed to make two operations. So we can convert this string to this. In the first operation, let's swap the last two characters. So it becomes this. The current face value of the string becomes 1 plus 10 plus 1, that is 12. It reduces. So this is a good operation. Now we can also do one more operation, but that won't make a change. So the final answer is 12. So let's come from with the answers. Yeah, 21, 22, and 12. So I think we understood the problem, and the constraints is n is 1e5, k is 1e9, and we have 10 to the power 5 test cases. So the sum of n over all the test cases is 10 to the power 5. Um, so there are many methods that we can try, like grouping all the ones together, or we can try multiple methods. But uh, let us try to uh, get to a more generalized approach of solving these kinds of problem. So let us look what exactly does each character contribute to the final answer. So let's say we had this string. So in this string, um, every ith character is part of di minus 1 and di minus and di. Sorry, this is di. In this, it contributes 1 star int of s of I, and for di it contributes, it is at the tens position, int of s of I. So every ith character contributes uh, uh, 10 in di and 1 in s of I minus 1. But it is important to notice that the zeroth character will only contribute to di, and the and the n minus 1th character will only contribute to di minus 1. uh, Rest all the characters will contribute to the same, to both di minus 1 and di. So if we have, let's leave the first space and let's leave the last space, and let's start our indexing from 1 and stop at n minus 2, n minus 1. So if we had a 1 at index 2, if we move this 1 to anywhere else, it will still contribute a sum of 11 to the final function f of s. But let's say we move some one to zeroth position. If we do that, then that one will only contribute a value of 10 to d0. But if we move this one to n minus 1th position, then that one will contribute a value of only 1 to dn minus 1. Hence, we realize that a 1 at index 0 will contribute a value of 10. A 1 at index n minus 1 will contribute a value of 1 to final answer, and a 1 at any other index will contribute a value of 11 no matter what. So there are actually uh, only two spaces that we would want our 1 to be, otherwise we don't care where our 1 is. So the best place for a 1 to be is the n minus 1th position. Other The second best position is the zeroth position. Otherwise, if it is between 1 to n minus 1, we don't care. It will always give a value of 11. Hence, with our k operations, we'll try to move. If there is no one at the n minus 1th position, what we will do is we will try to move some 1 to n minus 1th position. Second, after doing this, we will try to move someone to zeroth position. After this, we are done. Like, because all the remaining ones uh, will contribute 11 to f of s, right? So yeah, I hope this till this part it is clear. Now, uh, n- let's like, if we are given a string like this, which is the one that we'll want to move at the last position? Obviously the last one, because it takes the minimum number of steps to reach there. If Which is the one that will try to move at the first position? Obviously the first one, because it will take the minimum number of steps, right? So we'll always try to move the last one to the last position and the first one to the zeroth position. Now let's say we are only given one in our string, 0 0 1 0 0. So in this case, we'll try to move the first one to the last position if there are sufficient moves. Otherwise, we'll move this one to the zeroth position if there are sufficient moves, right? So let's take few examples. So let's say our string was 1 0 1. Let's say we have a 0 here only, and 0, and our k was equal to 1. Then we realize that we can't move the last one to the last position because it needs two operations. So what we'll do is we'll convert the string to 1 0 0 1 0 0, because we have in one operation the first one can move to the zeroth spot. Similarly, if this was our string and our k was 2, we can move this one to both end position, but since we know that moving this one to the n minus 1th position is better because it will contribute only 1 over there, so we'll make the string 0 0 0 1. Hence we have a greedy approach over here. I would say it's a constructive approach. uh, the solution is here. So let's look at how we'll code this. Yeah, so here is the code. We first scan all the test cases, then we take in the n and k, then we take the string, and we find the position of the first one and the position of the last one, and we count the total number of ones. So if s of p is not equal to 1, we continue, otherwise ones plus plus, and we keep on modifying we find we find the first one and we find the last one. Now if uh, add is basically the extra value that we are not counting the ones at 0 and n minus 1 position, will store their value in the add operation. So yeah, so if the number of ones is greater than 0 and we can reach the last position, so we'll make the last one move to the last position and subtract the operations from k, and we'll subtract the ones that are there in the middle, and will in the one at the last position contributes a value of 1, so we'll add it to add variable. Now now with the remaining moves, we'll see if we can move the first one to the first position, and if there are other ones remaining, and if they are, we'll move them, and the one at the first position contributes a value of only 10, so we'll add it to the variable add, and the final answer is 11 star ones in the middle plus add, that is the value of the ones at the first and the last position. Yeah, I, that should do for this problem.